All right, 2.3, we're going to use deductive reasoning to verify conjectures today. And by the end of the video, you should be able to apply the law of detachment and law of syllogism in logical reasoning. So far this week, we've been talking about inductive reasoning. Inductive reasoning, remember? Oh, I'm going to sneeze. No, I'm not. Just kidding. Excuse me. Thank you, Amanda. I know you're saying bless you. Okay, so inductive reasoning, you're going to use patterns and observations to make conclusions. So the easiest example I gave you was 2, 4, 6, 8, right? Then you could tell me that the next one is going to be 10. So that's just an example of inductive reasoning. Today we're going to start talking about deductive reasoning. Deductive reasoning is another form of logic. It's not where we use patterns and observations. It's where we use more like logic, rules, laws, science. That's deductive reasoning. So the first thing you're going to be doing is I'm going to be giving you situations and you're going to just tell me, is it inductive reasoning or deductive reasoning? And they like to put at least one question like this on the state test. So number one, there is a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, this myth is false. So did this person use inductive reasoning or deductive reasoning to determine that the myth is false? Inductive reasoning, remember, is patterns and observations, whereas deductive reasoning is science. Well, because this person observed it, that's inductive reasoning. So this is inductive reasoning because they observed it. If the person had said, well, because of the Earth's spherical hemisphere and the rotation of the Earth's axis, there's no way to balance an egg. If they were using science or something like that, that would be deductive reasoning. So number one is not using science, it's using observation, so it's inductive. All right, number two, there is a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above Earth. The moon is about 237,000 miles away from Earth. Therefore, the myth cannot be true. I remember reading this in my 6th grade science book, which shows you how far science has come, I guess. Okay, so here's the Earth. Supposedly, I remember this in my 6th grade book, there's the Great Wall of China, and you can, here's outer space, right? Well, actually with the way science is going and NASA and everything, you can actually go 180 miles above Earth and take a picture. And 180 miles above Earth, the Great Wall is barely visible. You could barely see the Great Wall of China. So if the moon is way farther, the moon is like 237,000 miles. Oops, that's a 2. So that's a lot farther than wherever they took that first picture. So if you could barely see the Great Wall from this point of view, clearly you can't be able to see it from this one. So because you were using science and logic, this is deductive reasoning. An example of inductive reasoning would have been if you went up into space on Monday and you couldn't see the Great Wall of China, and then you went up again on Tuesday and you couldn't see the Wall of China, and you went up on Wednesday and you still couldn't see it, so you would conclude that it's false. So that would be an example of patterns, and that would be inductive reasoning. I want you to try to do 3 and 4 on your own. Okay. Law of detachment. Law of detachment is a form of deductive reasoning. Law of detachment has one statement. It's called your P to Q. Okay, this is really important. I have to give you the hypothesis. Must give you hypothesis in order for you to know your conclusion. This is so important, and it's hard for people to understand. You have to know the hypothesis in order to get the conclusion. So, for example, let's say Joe. The PDHS, if you are tardy 5 times, 5 tardies, then you're going to get, that's tardies, then you're going to get Saturday school, okay? So Joe, let's say Joe is in Saturday school. Can you conclude that he had 5 tardies? No, Joe could have thrown a desk at something or done something ridiculous like that. He could have been in Saturday school for any other reason. You don't have to just have 5 tardies to go to Saturday school, right? So this is your if. This is your hypothesis. It must come before your conclusion, right? Just because I'm telling you that he's in Saturday school does not mean he has 5 tardies. So let's see if I can explain it to you in a better way. So that would be a false assumption. You can't assume Joe had 5 tardies just because he was in Saturday school. And that's what I mean by you need to know the hypothesis first. So here's an example. If the side lengths of a triangle are 5, 12, and 13, that's your hypothesis, right? Because it comes after the word if. So this is all your hypothesis. Then that's the conclusion part, right? The area of the triangle is 30 centimeters. Area equals 30 centimeters. So I'm going to rewrite this. Okay, so this is my hypothesis. This is my conclusion. Now I'm going to give you some extra information. The area of this triangle is 30 centimeters squared, 30 square centimeters. Can I then conclude that the side lengths are 5, 12, and 13? These don't match. They're going in opposite order. So this conjecture, this statement that somebody believes to be true, that the side lengths must be 5, 12, and 13, is false. It is invalid because I didn't first tell you because I went in the reverse order. This is if you're still stuck, think about it in terms of drawing a picture, and I'll come back to it. Number 6 is an easier example. Let's say, for example, here's another one. In the World Series, if a team wins 4 games, if you have 4 wins, then you will win the World Series in baseball. All right, so the Red Sox, so I'm done. This was my if, this was my hypothesis. The then part is your conclusion. So there's my conditional statement. Now I'm going to give you some more information. The Red Sox won 4 games, 4 wins. What can you conclude from this? You can conclude then that they're going to win the World Series. So let's look at their conjecture. Somebody said, well, then the Red Sox won the 2004 World Series. So that's what we concluded as well. Fantastic. This is true. This is a valid statement. Go ahead and try to do number 7. I know that that's tricky. Okay, last thing we're going to do, and then we're done. Law of syllogism has now 3 statements. You first have your one conditional statement. This is your first conditional statement. Then I'm going to go ahead and give you another conditional statement. Now, because these cues match, these are exactly the same thing. Your conclusion, that this means therefore, in conclusion, aha, you can push these other 2 things together. So let me give you an example. If a figure is a kite, so kite, like the things you fly at the beach, that's your hypothesis. Then, this is your conclusion. Then it is a quadrilateral. Okay, it has 4 sides. Sweet. That's my first sentence. Second sentence, if a figure is a quadrilateral, so this is my second sentence. If, that was your hypothesis, right? Then it is a polygon. This is your hypothesis. Okay, notice how the quadrilaterals, see how they repeat? You cross them out. What you conclude is, if it's a kite, it will be a polygon. And that's exactly what this one says. If it's a kite, then it is a polygon. So this is a true statement. You're going to go ahead and try number 9 and number 11. Let me try number 10. Number 10, I like it. Number 10 goes like this. If an animal is a mammal, so if you have a mammal, then it has hair. Sweet. We're all mammals and we all have hair. That's my first sentence. If an animal is a dog, it's my second sentence, then it is a mammal. Notice this one, this time I was trying to trick you, and I wrote it in the reverse order. Still, because you have these in opposite sides, you're going to push these 2 things together. So this one is going to be, if it's a dog, then it has hair. This is your conclusion. And let's read the conjecture and see if it's true. If an animal is a dog, then it has hair. Sweet, that's the same thing we said. So this is a true statement. All right, we're going to do the rest in class. And the fun fact of the video, almost, the word almost, A-L-M-O-S-T, almost is the longest commonly used word in English, where all the letters are in alphabetical order. Sweet, you are done.